Solution dilution. We often store solutions in more concentrated forms. It saves space, and it allows us to make whatever concentration we need. It's a little bit like getting a concentrated cleaner at the store, and if you're going to do some heavy-duty cleaning, you just dilute it a little bit. If you're going to mop the floor, you dilute it a lot. You can make different solutions out of it. So we often have to dilute this stock solution. They're called stock solutions. We keep them in stock. The place we keep them we call the stock room. So we do the same thing with these as you would do with that concentrated cleaner at home. We dilute it. You take the stock solution, a certain amount of it, and you add extra water. So this is the equation that we use to figure out how to make the dilution that we need. M1V1 equals M2V2. This is a little bit like one of the gas laws, right? But here M is molarity and V is volume. So the molarity times the volume of one solution, and if we take the molarity in moles per liter and we multiply by the volume in liters, what does that equal? That equals the moles of the solute. This equation works because the molarity of the one solution times its volume is the number of moles. When you just add water to this solution, the number of moles of solute stays the same. So it's very common to buy concentrated orange juice in the little can. It's frozen, right? And it's nice because it stores in the freezer and it's just there whenever you need it. How do you make it into something you can drink? Well, you take the concentrated stuff and you put it in a pitcher, and then you use that can and you add 3 cans of water. When you add water to the pitcher, does that change how much orange goodness stuff is in there? No. It's still the same amount of orange stuff that was in the can, but you've made the volume larger by adding water. You've diluted it so that it's drinkable now. Otherwise, it's just way too thick. So it's the same idea when we're diluting chemical solutions. So the molarity times the volume equals the amount of solute. In a dilution, we're not changing the amount of solute, we're just changing the volume and concentration of the solution. So it is very, very important to note that this applies only to dilution, not to stoichiometry. And if a tutor tries to get you to use this for a titration problem, tell them, no, Mrs. K said we can't do that. The issue is that sometimes it works, and other times it doesn't. And it's really not that much shorter or easier. And so it's better to do it correctly and get the answer right. So this cannot be used when you're changing compounds, when you have a chemical reaction. You can only use this if you've got the same substance in both solutions. A note on lab safety: when we're diluting acids, we always add the concentrated acid to the water. We never add the water to the concentrated acid. That process of diluting an acid is an exothermic reaction. It can generate a lot of heat. It can generate so much heat that it causes the solution to boil. And that can cause it to splatter out and get all over you. So you never ever add water to concentrated acid solutions. So let's do this example. How much 6 molar sodium nitrate solution would you use to make 0.585 liters of a 1.2 molar sodium nitrate solution? So of course we have the title here telling us what kind of a problem it is. But here we've got sodium nitrate, and the other solution is also sodium nitrate. There's no chemical reaction occurring here. So we're going to use M1V1 equals M2V2. So M1V1 equals M2V2. So let's take these numbers out and figure out what they are. So we have 6.0 moles per liter. Because it's still sodium nitrate before and after, we don't have to write down the chemical formula. We've got 0.585 liters of solution, and we've got 1.2 moles per liter of the sodium nitrate. What we have to do here is we have to identify which volume and concentration go together. And we need the words in the problem to help us figure that out. So how much of this to make 0.585 liters of this? So 0.585 and 1.2 go together. You can call them 1, you can call them 2, it doesn't matter as long as you pair them up correctly. So this is a molarity, this is a volume, and this is a molarity. And we can tell from the words that these two go together, so I'm going to give them the same number. I'm going to call them 1. This other molarity then must be 2. So I have 3 of the 4 letters, 3 of the 4 variables. So I'm going to solve for the one that's missing. So the one that's missing is V2. So I'm going to rearrange this equation. Divide both sides by M2, so that cancels out. And I've got V2 by itself. So V2 equals M1 times V1 divided by M2. I labeled my numbers, and now I just need to put them together. So M1 is 1.2 moles per liter. Volume 1 is 0.585 liters. Divided by, down there I've got M2, which is 6.0 moles per liter. Before you do the math, look at the units and see if those are going to work out. So here I've got moles per liter, and there I've got moles per liter. I could cancel this liter and this liter, but that's going to make things more complicated. It's easier to cancel moles per liter with moles per liter. And so I'm left with a unit of volume, and that's a good sign. So now I do the calculation, 1.2 times 0.585 divided by 6. And looking at significant figures, the smallest number of significant figures is 2. So my answer is going to have 2. So 0.11, there's 2 significant figures. The only digit that my calculator shows me is a 7. You could write down a 0 after that if you want to, but it doesn't really do any good. And the unit is liters. And then I would round this to 0.12 liters. So I would take 0.12 liters of this more concentrated solution, and I would add water until the volume is 0.585 liters, and then the concentration will be this number, which is lower. Any questions? So here's an illustration of making a solution by diluting a more concentrated solution. So we're making 5 liters of 1.50 molar KCl from a 12 molar stock solution. This is much more concentrated. This is not an acid, and so we don't have to be concerned about adding concentrated acid or adding water to concentrated acid. So first we're putting in 0.625 liters of 12 molar stock solution. Because the calculation down here, come on pointer, there we go. M2V2, the concentration of the second one is 1.5 and the volume is 5. So you multiply those, that gives you 7.5 moles. And then that means that 12 times the volume of the first solution has to equal 7.5 moles. That's how we get the 0.625 liters. So you measure this out, you add it to a flask, and then you add water until the total volume is what was specified. Then, of course, you need to mix it.